Harmful algal blooms, or otherwise known as HAPs, are becoming more and more prevalent in the United States, impacting systems such as drinking water systems, fisheries, ecosystems, and tribal communities. The main challenge is that most monitoring approaches only detect blooms after they've already formed, which leaves communities with little time to prepare or respond. This problem is especially compelling because climate change is accelerating environmental conditions that drive harmful algae blooms, such as warmer surface temperatures, more extreme rainfall, and increased runoff. These patterns are appearing nationwide, and blooms have now been detected in all 50 states. If we could predict harmful algal blooms weeks or months before they occur, we could shift from reactive emergency response to proactive planning and prevention. Our project asks whether we can use global climate model outputs, specifically CMIP6 data on temperature, precipitation, runoff, and stratification related variables, to predict when and where harmful algal blooms are most likely to occur. We want to determine if climate signals provide enough information to generate early warning forecasts that tribal and coastal communities can act on. To answer this, we are building a predictive modeling pipeline that links CMIP6 climate variables with historical harmful algal bloom observations. We will test a range of models, including logistic regression, generalized additive models, random forest, XGBoost, and temporal sequence models to capture both linear and non-linear relationships between climate patterns and bloom formation. We will regrid climate data to observational scales, engineer predictors like heat accumulation and rainfall anomalies, and train models to detect the climate signatures that precede bloom events. We will measure success by whether the model can reliably forecast harmful algae bloom risk, produce spatial risk maps and lead time alerts that communities can use, and whether climate-driven variables consistently improve prediction accuracy. Ultimately, our goal is to demonstrate that climate models can be leveraged to provide meaningful early warning systems for harmful algae bloom management.